Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter, well, we're going to talk about MSA, but we're going to talk about MSA for attributes, for some kind of cosmetic inspection maybe. So let's imagine we were inspecting the quality of the print on my felt tip pens, and we were saying the print is of good enough quality, it's a pass. The print is defective, and someone's saying that has to go in the bin or be reworked or whatever. So it's not measurable. We're not measuring the diameter or the weight or something like that. We're inspecting the cosmetics, and of course it's either pass or it's fail. That's attribute data, and that's a different style of MSA to the MSA that we've talked about previously. Just before we start, if you've got any comments about the video, especially if you want to say that you're not happy with the video, please leave a comment rather than just a thumbs down. If there's anything that I can help to correct or I can help further with, I'll happily make additional videos. So please leave some comments in the area below this video. It's very helpful for the channel. But let's take a look at this. We're going to take a look at MSA for attributes. Pass and fail. Often it's some kind of cosmetic inspection, but it doesn't have to be just cosmetic inspection, but it often is. So some important things about setting up the MSA for attribute data. The first thing to say is what you're going to have to do, of course, you're going to have to get some samples for the measurement systems to inspect and to decide whether they're good or bad, whether they're pass or fail. Now normally what we do is we get 20 samples, and unlike the other MSA, the MSA for variable data, where you would randomly select the samples, what you're going to do here is actually specifically select the samples, because for the 20 samples they must be 10 that pass and 10 which are defective. And it must be however many samples you offer up to the measurement systems, and I usually like to offer up 20. However many you like to offer up to the measurement systems, it must be a 50-50 split. And the reason for that is because all the statistics that come with this method are all worked out as percentages. So if you decided to offer up 10 that were pass, 10 good ones, and 2 that were fails, if I make a mistake when I'm assessing the good ones, well, I make one mistake out of 10. So the mistake, I'm only wrong 10% of the time. But of course, if I make a mistake here, 1 in 2, well, suddenly I'm making a mistake 50% of the time. And now what you're getting is you're getting a bias through the statistics. So in order not to create a bias in the statistics, what we're going to do is we're going to make sure that we have 10 that pass and 10 that are defective. Now, of course, what this also means is that someone has to decide the true nature. So some expert has decided the true nature of these samples. Now that's not something that we do in variable MSA. There is no real size for a part, and if I hold certainly a metallic part in my hands, then the size will change. So in a sense there is no real size when you're working out variable data, but there is a real state for these parts. So someone in the company has to be the holder of the standard, and they've assessed the 10 that pass and the 10 that fail. Okay, so that's really important that it's 50-50 when you set them up. And then all you're basically going to do is you're probably going to pick an operator, because often these things are people. Operator 1, operator 2. Could be an inspection machine, by the way. These days there's lots of inspection cameras and things, so this could be a camera if it's an automatic inspection process. And then what you're going to do is you're going to offer up the 20 parts, and you're going to give them a little 20 question exam almost, and you're going to see how many they get right. So if operator 1 gets 18 out of 20 correct, and operator 2 gets, let's say, 16 out of 20 correct, the first statistic that you're going to work out is what's their overall effectiveness, and it's just a percentage. So in this case, this system is 90% effective. It's very simple. This system over here is only 80% effective. So the first thing you're going to work out is the overall effectiveness of the system. Now, by the way, 80% is still an acceptable system. People often look at these numbers and they think, well, I want it to be 100% correct. When you're doing cosmetic inspection, it's never going to be 100% correct, and 80% is the cutoff. If you're below 80%, that's the point where you'd want to do some improvement work on this. So first of all, the first thing we've worked out there is what's known as the effectiveness. How effective are the measurement systems? Then the next thing you're going to work out is the chance of a false reject. Okay, so what's the chance you're going to get a false reject? And of course that's going to be defined effectively by the percentage of mistakes that you've made here. So if you've made 1 in 10 mistake here, then there's a 10% chance of a false reject. Then you're going to get the opposite of that, of course. False accepts, and the same thing. So we look at how many mistakes have got made with these parts. Let's say 2 have got made in that case. So there's a 20% chance of a false inspect. And then the final number that you work out is the bias. Now the bias is which way are we biased here? Are we too tight or are we too loose? Okay, too tight or too loose. Now you can see here, look, that we're accepting more mistakes. So we're actually too loose. Yeah, now, so you look at these two. Now often what people do is they divide one by the other. And you want the bias to be above 1. Now in this case we're below 1. We are at 0.5. So the bias would be going in the wrong direction. So here if we said this person was 90% effective but they had a bias to being too loose, we would still say they need work, they need help to refresh their standards. So they're the statistics that you work out in an MSA for attribute. You check to see if they are overall effective. You check what the bias, you check what the false reject rate and false accept rate is. You check that the bias, they are too tight. They are keeping the mistakes in-house instead of pushing the mistakes to the customer. So as long as we're too tight, the mistakes that we're making stay in-house. And of course that's the way you get around the problem of, well, we're making a mistake 10% of the time, yeah, but we're keeping them all in-house. And that's really what you should be aiming for. So it's a very simple technique. The important point though is this 50-50 for the passes and the fails. If you get this wrong, you will bias the MSA and create false results. So There's MSA for attributes. I personally use SPC Excel software to do this. If you go looking on my YouTube channel, you will find a little tutorial on how to do an MSA with attributes for SPC. I'll just put this down. SPC Excel software is my software of choice, and the software basically will work out these statistics for you. But MSA, super important that you use it, of course, because it's part of the problem. When you've got a defect rate, part of the problem is the fact that your measurement system is making mistakes, and of course especially if someone is biased and they're very, very tight with their standard, they can be making the defect rate look very dramatic when actually the process hasn't changed at all. You've just put a tighter operator onto the process. So MSA, it is crucial to you getting your process capability improved. Usually when you've got a problem, measurement system is going to be part of it. That's how to do an MSA for attribute, and of course there's also an MSA for variables should you need it. MSA for attributes.